Hey guys, welcome back to my channel. In this video, I'm going to show you how to create dynamic RFM customer segmentation in Power BI. In one of my documentation, I covered a summarized version of RFM segmentation where the RFM score and customer segments are calculated using the entire dataset as one static snapshot. And in this video, we will take it a step further. So instead of creating a static summary table, we will build a fully dynamic RFM model using text measures only. So the customer scores and segments automatically update based on the selected evaluation year. So here, for example, if we select year 2020, this year will be our evaluation year. And if we select 2018, this year will be our evaluation year. So for those who are not familiar yet with the term RFM, I will explain it briefly. So RFM customer segmentation is a marketing and analytics technique that groups customers based on recency, frequency, and monetary. Recency indicates how recently they made a purchase. Frequency indicates how often they purchase, and monetary indicates how much they spend. So this approach helps businesses better understand customer behavior and create more effective strategies for retention, engagement, and growth. And in this analysis, RFM represents a customer's lifetime journey, not just a single year snapshot. So for this specific analysis, here's how each component is defined. So recency is equal to number of days since the customer's last purchase, calculated as of the selected evaluation year. And frequency is equal to the total number of purchases accumulated up to the selected year, and monetary is equal to the total spending accumulated up to the selected year. And to emphasize important information, I also use the highlighting indicators to make the table easier to read. So here we can see the blue customer names that represent new customers. So these customers had no purchases in the previous year but became active in the selected year. And we can also see the grayed out customer names. So these customers represent churned or inactive customers. They made no purchases in the selected year and therefore have no current year values. Recency is displayed in days, which is calculated as the number of days between a customer's last purchase date and the latest date in the selected year. For example, we can see here that Adam has recency value of 104 in 2018. So it means that it has been 104 days since Adam's last purchase. And then if the recency variance is 365 days or more, it will be highlighted in red. So this indicates that at least one full year has passed since the last purchase and signals a potentially churned or inactive customer. So for frequency, it represents the total number of transactions per customer, which is calculated as a running total from the earliest date in the dataset up to the selected year. Here, for example, in 2018, Alisa has transaction count of 1, and in the previous year, she also has the same transaction count. So it means there is no change in her transaction count, meaning that she has not made any purchase in 2018. So the absolute variance will be 0 and the relative variance also will be 0%. So if both absolute and relative variance are 0, it means no new transactions occurred in the selected year, which is another strong indicator of churn or inactivity. And for the monetary, it represents the total customer spending, also calculated as running total up to the selected year. So here we can see, for example, Jim has a total spending of $611 in 2018, and in the previous year he only spent $35. So it means there's a huge increase in his total spending, which is amounted to $576 or around 1,600%. But if there's no change in spending compared to the previous year, the customer did not make any purchases in the selected year and is considered churn, like in this case, as you can see. Now I will begin the demonstration. So for the first step, we will summarize customer data with text. To build a dynamic RFM model, we first need to prepare customer level metrics. Instead of using a summary table, we will rely entirely on text measures, allowing everything to update dynamically based on the year slicer. So first, we will determine the last order date per customer. So to calculate recency, we need a measure that returns the number of days between the last date of the selected year and the customer's most recent purchase date. So this measure must handle different filtering scenarios. So in our dataset, the year spans from 2017 to 2020. So for the first scenario, if a customer's most recent purchase is in 2020 but the user selects 2019, then the measure should return the last purchase within 2019. And for the second scenario, if the customer's most recent purchase is in 2019 and the user selects 2020, then the measure should still return 2019, even though it falls outside the selected year. So to handle both cases correctly, we use this measure that calculates the days since last purchase per customer. So this measure calculates how many days have passed since the customer's last order, measured up to the end of the selected year. So for the detailed explanation of this measure, you can visit the related documentation page on my website. The link is in the description. The next step is to calculate the total transactions per customer. For the frequency score, we need to calculate the cumulative number of purchases per customer up to the selected year. So the logic is handled by this measure. So it counts how many distinct orders a customer has made up to the end of the selected year. For the detailed explanation of this measure, you can visit the related documentation page on my website. So let's take a look at the example. So here we have the selected year of 2020. You can see here that the AC column displays the total cumulative counts up to the selected year, which is 2020, and PY column displays the total cumulative counts up to the previous year, which is 2019. So for example, for Adrian Barton, we will see the the transaction counts when we select the year 2019. So here we can see that in 2019 Adrian has the cumulative transaction counts of 5, and up to the previous year, which is 2018, he has the cumulative transaction counts of 2. The last metric we need to calculate is the total customer spending. So for the monetary score, we need to calculate the total spending up to the selected year, again using a cumulative approach. This is handled by this measure. So it calculates the total sales value a customer has generated up to the end of the selected year. So for example, here, if the selected year is 2019, the AC column for the monetary will display the total spending up to 2019, and the previous year or PY column will display the total spending up to the previous year, which is 2018 in this case. So once the core metrics are ready, the next step is to convert them into standardized scores. So each RFM dimension is scored from 1 to 5, making it easier to compare customers with very different behaviors. So for this case study, I used the Bloombridge RFM framework. But keep in mind that RFM is highly flexible, and you should always adapt thresholds and segment definitions to match your business needs. So first of all, we will assign the R score. We will use this measure to assign different score based on the recency. So this measure converts recency into a score from 1 to 5. So the fewer days since the last purchase will get the higher score. For the F score, we will use this measure to assign the score. So this measure converts the total number of purchases into a score from 1 to 5. So more purchases equal a higher score, and vice versa. And then for the M score, we will use this measure. So this converts total spending into a score from 1 to 5. So higher spenders will receive higher scores. And then after we assign each score, we will combine all these 3 scores into a single unified RFM score. So using this measure, we combine the RF and M scores into a single 3-digit code for each customer. So let's see here. So we'll set up the table and we'll drag the customer name to the columns, and then we'll display the R score, F score, and M score. So let's take the year filter here. Okay, so here we have each RFM score for each customer. and then the unified score is the combined 3 digits of the RFM score. So we can see here the combined score is 511, 531, 531, 532, and so on. So with the RFM score in place, we can now assign customers to meaningful segments, as we can see on this table. So to assign a segment to each customer based on their RFM score, we will use this measure. So this measure maps each RFM score to a segment name, such as champions, loyal, potential loyalists, and so on, based on the Bloomridge framework. So for the description of each segment, you can read from their website. So now we will place this measure to the column field. Now as you can see here, it doesn't show anything. This is because we have this function, so it only returns the result when the customer ID is detected. So since we don't have customer ID on this table, the measure returns blank. So we can just simply place the customer ID to the field. As you can see here, now the segment appears. And if we change the selected year, the segment will change dynamically. Before constructing the final table, we need to calculate the previous year values and variances following IBCS condensed principles. As we can see from the final table, it displays not only the AC values for each metric, but also the PY for previous year, the absolute variance, and the relative variance. So to calculate the PY, absolute variance, and the relative variance, we only need to use one reusable function, which is often called user-defined function, or UDF. So we can just simply use this function to calculate measure for each metric. So here for frequency, we can just use the AC frequency. For the monetary, we can use the AC monetary. And for the recency, we can just use the AC recency. Let's take a look at the UDF. So this function returns PY, AC, year-on-year and year-on-year percentage from a single measure. So all time intelligence logic stays consistent. So for the detailed explanation of this UDF, you can read on my related documentation page. In the final table, we want the total row to show the number of customers for both PY and AC. However, this cannot be done directly using the customer name column from the dim customer or customer dimension table. Since it's a text column and not a measure, Power BI will simply repeat text on the total row instead of calculating a total. So to solve this issue, we need to use a DAX measure. So on the detail rows, the measure displays individual customer names, and on the total row, it returns the total customer count for both PY and AC. So this can be done using the following measure. If you'd like to know the detailed breakdown of how this measure works, you can find the full explanation on the related documentation page on my website. So now we can simply drag this measure to the columns field, and you can see that on the detail rows, it displays the customer names, and on the total row, it displays the number of customers for both PY and AC. And this can change dynamically based on selected year. Next, we want to sort customer names by value rather than alphabetically. This way, the most valuable customer segments appear at the top of the table, helping stakeholders focus on what matters most. So to achieve this, we need to create a ranking measure that assigns a numeric value to each RFM segment. So this measure converts segment names into numbers, so Power BI can sort them in a logical, business-friendly order. Now we can simply add this ranking measure to the columns field. And then we will sort the table by this column. And now, as you can see, the most valuable segment appears at the top. For the final step, I will demonstrate how to construct the final table. And that's how you build a fully dynamic RFM customer segmentation model in Power BI, driven entirely by text and responsive to your selection. If you find this helpful, don't forget to like, subscribe, and let me know in the comments which topic you'd like me to cover next. Happy learning, and I'll see you in the next video.